So at the 1 prime place there is this OH and 1H, and here it is like this. It is a 2 prime. It is a 2 prime. This carbon is the 2 prime carbon, and out here it is like this. And this is the 3rd prime carbon, and out here too, like the 2 prime carbon, it is like this. And here at the 1 2 3 4 fourth number of carbon, it is like this. Is H, and this carbon is like this. Here one OH is attached to it. So this is the first, or the 1 prime carbon, this is 2 prime carbon, this is 3 prime carbon, this is 4 prime carbon, and this is the 5 prime carbon. Now in this 1 prime carbon, now in this 2nd prime carbon there is one OH, right? And this is the ribose sugar. But in deoxyribose, that is the sugar used in, or the pentose sugar in DNA, deoxyribonucleic acid, that in out there the ribose sugar is not present. Out there deoxyribose sugar is present. Now what is the difference? This O is not present, this oxygen is not present, only this H is present, so it is called deoxyribose sugar. So in out here also I am drawing the deoxyribose sugar too. Okay, but later on I would be drawing it while I am doing the DNA. So okay, let's do it out here. Now here I'm going to do the DNA contains that is the deoxy, its full form is deoxyribonucleic acid. Now it has the pentose sugar in it is deoxyribose sugar, as I already ribose sugar, as I already said. Now it is like this. Oh sorry, out here the oxygen is not there. In which carbon? In the second prime carbon the oxygen is not there in deoxyribose. And out here OH, out here H. Now see, you can remember it like this, that as per as I remember, that every carbon has some distinct feature or function. Now what are those? First of all, this carbon has OH, and it gets attached. This OH leaves a bonding with I mean out here a nitrogenous base gets attached. A nitrogenous base gets attached, and when the nitrogenous base gets attached, then a water molecule is passed out, or not actually water molecule, it H2O is passed out. I mean the H from here and OH from the nitrogenous base is passed out, and this forms a molecule. I mean yes, molecule. And this out C, and in 2nd prime there is OH in ribose sugar, and in deoxy there is nothing. So this is also a distinct feature of this 2 prime. And in the 3rd prime the distinct feature is that it get attached to the and it gets attached to the phosphate, to one end of the phosphate. And this 4 prime, it has this out of this ring there is one carbon. This is the special feature of this. And this outside carbon, this is 5 prime, that is the 5 prime carbon. It has it has this hydroxyl, and it also gets attached to phosphate, and this is it. And then now let us go and see the nitrogenous bases. Wait a minute, let me turn the page up over. So okay, here I am going to show you the nitrogenous bases. Now okay, now in RNA and DNA, let us first know the nitrogenous bases by short names, that is A, T, G and C. Now these are the nitrogenous bases and U. In DNA, A, T, G, C is found, and in RNA, A, G, C, U is found, and T is not found in RNA, although found at times, but in very minimal. That is not required for your syllabus, and in class 12 standard or 11 standard or high secondary. And in DNA, this T is present, and in RNA this U is present. Okay, this is present in RNA and this is present in the DNA. Now that now A and T, wait, they base pair with themselves. I mean, they, in a DNA they get attached through hydrogen bonding, and in G and C they also get attached, or A and U gets attached. Now what is A? Let us see. Now let us, there are two types of nitrogenous compounds, that is purine and pyrimidine. Now what is the structure of purine and what is the structure of pyrimidine? Now let us first draw the structure of pyrimidine. Okay, so it is a 6-membered ring, but not 6 carbon ring. It is a 6-membered ring. Now here it is not carbon, here it is nitrogen, and here too it is nitrogen here. Okay, so just before this nitrogen there is one double bond, and after skipping this one there is another double bond, and after skipping this one there is another double bond out here, and this is it. And here is one H. Sorry, I have done a mistake. There is no H out here, and here is, if you want to show the H, here is one H, here is one H, and here is one H, and here is another H, I mean hydrogen. So this is the structure of pyrimidine, and out here the numbering is like this: 1, 2, 3, 4, 5 and 6. This is the first carbon. This nitrogen is given the first number. And now let us see the structure of purine. Now purine is also it is a 9-membered ring, and it has 2 rings. See, it is, you can just draw this ring and then attach this one to it. So here I am going to just do the same, that the nitrogen places, then out here the double bonds, and out here this just attached to the carbon is a nitrogen and another nitrogen, and out here wait a minute, and out here there is a double bond out here, and here this is the first, not in this case, this one was the first member, and in here the first member is this one, then it is this one, then this one, in like this. This is 1, this is 2, this carbon is 2, this nitrogen is 3, this carbon, this junction carbon between the 2 rings is 4, then this is 5, and then this is 6. Now where you ended 5, from there the nitrogen next to it is 7, as you have completed out here 6, so it is numbered as 7, this is numbered at 9, then this is numbered at 8, and then it is numbered 9. And so it is done. This is the purine and this is pyrimidine. Now A and G, see out here the A and G. A gets attached to T or U with two double bonds, with two hydrogen bonds, and G gets attached to C with 3 hydrogen bonds. Actually, hydrogen bonds are not shown as straight line. This is just this, just for the sake of just for showing you. I just showed that. That is actually not the right thing. And pyrimidine, out here it is T, U, and C. Now, what are the full forms of A? A is adenine, and G is guanine, and T is thymine, and U is uracil, and C is cytidine. Wait a minute, see cytidine spelling, Cytidine. So let us first see adenine. Now let us first draw the purine. Actually, straight line. So here is our purine. So in purine we add what is this called, amine group here in the 6 carbon. We do this, okay, and we attach amine group, and this is the adenine, okay. And in adenine, oh, I forgot to show you that in purine there is one H out here in the 9th carbon, okay. And so in adenine also, in the 9th carbon there is a H, and using this, I mean out here the adenine and all the purine which are purine, those which are purine, they at the 9th carbon they get attached to the carbohydrate, that is the pentose sugar. And in purine, from the first carbon they attach to the purine sugar, but here is no H, right? But in case of T, U, as they are derivatives of purine, not pyrimidine, but derivatives of pyrimidine, so this N contains one H, and using that they combine with the sugar, carbohydrate sugar. And I said you one wrong thing. 1 minute, I said you one wrong thing, that is here actually both this OH is removed. Both this OH is removed, not only this H is removed, both this OH is removed, and OH2 is removed, but from here the both the OH is removed, and from the nitrogen plus base only the H is removed, okay. I said that wrong. And here I said about adenine. Now I'm going to say about guanine. Now let us first draw the purine, as guanine is a derivative of purine, and let us first draw the purine. I have done a mistake again. I'm doing it again. I did a mistake. Okay, so I'm going to do what was I going to do? What was I going to do? Oh, I did adenine. Now I'm going to do guanine, or whatever you call it. So at first I'm drawing the purine, and here I'm doing this, then doing this. Okay, and here is our purine. This is the purine. Let me write out here. Purine also I have written wrong. Now here it is purine. So I showed that adenine is when in case of adenine out here this amino group is amine group is attached. This is adenine. Now I'm going to show you guanine. Now I'm drawing the purine again. Here is the purine. So out here I attached the amine group to this carbon, that is the 1 2 3 4 5 6 number carbon. And out here I am going to attach this amine to this carbon, and out to this carbon I am going to attach two I'm going to attach an oxygen, or I'm to make this a carbonyl group, that is a ketone. So out here see the number of hands of carbon is getting 5, so I have to remove this. So it is the structure, or I'm drawing it again. Here is the structure of guanine. So here is the structure of guanine I'm drawing. Here at first I'm drawing the what is this, purine. Then out here we will not draw that hand of carbon or whatever you say. Yes, this is, and here this one. So this is our guanine. Now next we are going to do pyrimidine, the derivatives of pyrimidine, those nitrogenous bases.